Ramu, a small farmer cultivating crops in the village Palampur of India. I'm sowing my potato seeds now and see the bountiful harvest I'll have after a year. What are these dot-like structures on my leaf? Well, never mind. Let me continue my work. All my crops are devastated. What should I do now? I don't have anything to feed my family. Well, never mind. Let me continue my work. Stop! Do you know that these spots in one leaf will eventually destroy your entire yield? Do you know that 20 to 40% of global food production annually is lost to crop diseases? Global food security is threatened. Oh, but is there any solution to this problem? Yes, there is. Neural networks are the solution. Machine learning has a subset called deep learning, under which there is something known as a neural network. I have built and trained a type of neural network called a convolutional neural network, or a CNN, that does multi-class classification and detects crop diseases. Let me explain how I did it. I wrote my code on Kaggle and used a Kaggle dataset for my code, which consisted of 87,000 images of crops belonging to 38 classes. I had disease-borne and healthy versions of 14 different types of crops, each of which represented one class, such as apple scab, tomato late blight, or potato healthy. I divided my dataset into 3 parts: training, testing, and validation, and then pre-processed my data using image data generator, where I assigned it a batch size, target size, image size, color mode, and class mode. I used transfer learning and imported Google's EfficientNet B5 model. I used EfficientNet B5's base model without the top and initially freezed all the 24 base layers. However, I added these 6 layers to the base: a dense layer with 256 units, an activation layer with rectified linear unit activation function, a batch normalization layer, a dropout layer, a dense layer with 38 units, and finally an output activation layer with softmax activation function. Then I compiled the model specifying the loss function, optimizer, and metrics. Finally, I trained my model for 15 epochs and also used techniques like early stopping and reduced LR or learning rate on plateau. However, I also wanted to fine-tune my model, so I loaded the trained model and set EfficientNet B5's last 10 layers on trainable. Once again, I compiled and retrained my model. I'm proud to say that my model currently has an accuracy of 89%. However, I plan on further improving it by expanding and diversifying my data sets even more, increasing my model complexity, and experimenting with my hyperparameters. Let's use this model on your farm, Ramu. First, the model has to be loaded. Then the image to be tested has to be input and the code has to be run. The model will then output the predicted class, which will be a number from 0 to 37. A key will also be provided to the user, which will inform the user about the disease corresponding to that class number. Hey Ramu, my model says that your potato crop is affected by late blight. Oh, but now that I know precisely what disease my crop is being affected with, let me start working on the solution. Yeah! My yield got saved! All thanks to you, and of course, CNNs. Yeah!